This is my handle and my company's handle. Quick few words about Datadog. Datadog is an observability platform that allows you to track logs, status, and performance metrics across your applications and organizations. We do offer over 450 integrations, including, of course, Android, iOS, React Native, and soon Flutter. So first, basically what we're going to talk about is all the lessons learned from writing an open source SDK for Datadog, Android SDK for Datadog. A lot of this might echo some of the things that Nicolas Cardi talked about in the previous talk in the room next to this one. But this is from a different perspective, so hopefully this is not going to be just a copy-paste. So where are we coming from? We're coming from basically 2.5 years ago, first commit of the Android SDK project. And since then, we've had over 2,400 commits with 3 main developers. But we had overall 20+ contributors, both from the company itself, but also from the community, which is one of the good things about being open source. We published around 30 versions of the SDK, and we have 10 artifacts. So we have 10 different artifacts on Maven that are built from the same repository. And so basically, we have a library, and the first thing that we want to do when we want people to use it is making sure that it is safe. Because reliability is key. When you publish a library that is going to live inside other people's application, you need to be sure that you're not going to cause any harm to the host application. Our library lives in hundreds of applications deployed on 100,000 devices, so we need to be sure that we're not going to crash by mistake. One of the key things is that we need to notice the potential issues from our SDK as soon as possible. This is a graph that says basically what's the cost of fixing a bug depending on how late you find the bug. If you find it during completion time or development time, it's very easy to fix. If you wait for CI or code review, it's going to be a little bit harder. When you wait for dogfooding, it's going to be much, much harder, and production, it's going to cost a lot. The main reason for that is that once you've got code that ships into production, a lot of things you can't change because features are already there, and people are expecting the feature to stay the same. So you're kind of stuck with what you have. But everything that happens before it ships, basically you still have the time to change the API and to change the algorithm. So we want to make sure that the code is safe, and our objective, one of our objectives, is to have zero crash caused by our code at Datadog. So for that, we use everything that can happen before the SDK is released. Static analysis, code reviews, all the kind of tests that you can think of, and of course, real-life use cases. So for static analysis, the main tool that we're using is Detect. So for those of you who don't know Detect, it's a static analysis tool for Kotlin, which already provides a lot of useful stuff to make sure that your code follows the best practices. But one of the cool things about Detect is that you can write your own rules to say, oh, I'm going to look for a specific pattern in my own code, and if I find this pattern, I'm going to raise an issue. So these are the few rules that we wrote ourselves to extend Detect. So one of this is forbidding throwing exceptions. So basically, unless you're on the top-level public API, so basically the user provides a configuration with an invalid argument, we can throw an exception. But anything internal, we forbid the use of the throw exception statement. Likewise, we forbid the use of check, require, or the double bang operator in Kotlin, because all of those underneath are going to throw exceptions. And because we have this, we also want to make sure that any code that we're going to call from the Java standard library, the Android framework, or any library that we use, OKHTTP, Compose, whatever, we're preventing calling any method that's going to throw an exception without the relevant try-catch statements. So we've made a rule that's just, it knows a list of all the APIs that exist and say, oh, calling this, like calling file.write or something in Kotlin, this is going to throw potentially an I/O exception. So we know that, and whenever we call this, we want to make sure that, oh, you need to wrap this into a try-catch statement. And with this, we've made sure that, like 99.9% sure that there is no exception that could be thrown without us knowing it. On top of this, we have a mandatory code reviews. So every single line of code that is written by one contributor needs to be read by at least one other person and needs to be validated and proved. The main effect for this is that it's going to increase the readability of the code that we write as a team. Because, well, if every line of code is read by someone else, you're sure that that person understands what you've written. And if it's not understandable, it's not maintainable, so we're going to have a rejection from the code reviewer, and the code is going to be rewritten to be more readable. Also, one of the good things is that it's going to generate discussion. Discussion about the data structure, the design patterns, or third-party libraries. So basically, this is also a place to learn from others and improve as a whole the patterns and the way we write code in the team. And then we have lots of tests. And maybe some of you have heard about this quote, which is testing is doubting. Like, and I do agree, testing is doubting. But most of the people that use this implies that doubting is a bad thing. Doubting is good because you need to doubt that your code works to write good tests. And you need to doubt that your code is going to work until you have proof that it does work. And that's what the tests are here for. The tests are going to run against your code, and they're going to say, yeah, actually, it does work. So we do have a lot of strict policy on the testing. We do try to have high coverage, not 100% because not every line can be covered, but we try to have the highest possible one. We have a policy to deal with flaky tests as soon as possible. So basically, so we have monitors that tells us, hey, by the way, this test is flaky. And whenever we have a flaky test, so basically a flaky test, it's like a test that's going to fail in CI on a part of the code that you didn't touch. And this means that there is something that is random or that is not properly done in your test that makes it fail randomly, seemingly. So understand, this means, if this happens, this means that something is not well understood or that you don't, you're not the masters of your own code. So flaky tests need to be dealt with as soon as they are visible. And the main goal is to make sure that at all time we're confident with our test. Because the more confident we are on the test that we write, the more confident we can be on the code that is tested. And then we do have real-life use cases. So of course, we are documenting the SDK inside our own applications, but we also try to use our SDKs into open source applications that are written by other people. The goal is that basically the library is going to be used by many developers, and there are many ways to write an application with different patterns, with different libraries. And basically, you want to be sure that your SDK or your library is going to be compatible with as many applications out there as you can. So trying to test it inside lots of different complicated code bases and not just an LOL project is going to make sure that we can find where our SDK is not compatible with something. So the one that we use is a Wikipedia client, the Reddit client, one of many Reddit clients and one of many Hacker News clients that exist out there. And there are thousands of Android open source application on GitHub, so it's very easy to find a few one, try and build it, and then add your SDK in there. Then, still on the matter of being safe is the matter of privacy. We all know that this is something very important. GDPR has been around for a few years now, and so we try to make sure that our application cannot break the privacy issue for our customer and the end users. The main thing is that we try to leverage the sandbox storage, which is basically the dedicated space on this that is reserved for your own application, and only your application can read and write from it, and no other application on the system, and not even the user, can read and write from it. So this means that the data there is protected. On top of that, we try to use a cache whenever possible. The cache folder, again, it lives in the sandbox, but one of the good things is that if the system is low on memory disk, on this memory, it's going to clear the cache folder for you. So basically, you can store data that's not critical for the work of your library in there. And basically, if the OS needs some space, it's going to clear it, and you don't have to manage it. Another good thing is to add a GDPR option. So basically, you want to make sure that, hey, let the customer, the developers tell you your library, what's the status of GDPR. So what does the end user think about their own privacy? Datadog is a tool that collects data. So of course, we're very concerned with this. And so we have an option that says, hey, by the way, the user consent to being tracked, or they don't consent, or they don't know, and we'll tell you whenever we can. And we try to make sure that we don't track anything that the developer is not aware of. On this topic, Google Play now asks the applications to provide a data collection declaration that says, hey, this is the data that the application is collecting, and this is visible on the Play Store, so customers can know what data is collected. If your application has anything to do with data collection, you should write documentation about this and help the customers add this into their own data collection form on the Play Store. So now we have a library that is safe, or we have all the monitoring to make sure that, yes, it is safe. Now what we want to do is making it efficient, because no one wants to have a library that's going to make the app slow and janky. So one of the first things is to make sure that you limit the library performance impact. So you need to offload heavy computation to either background threads or even workers. The work manager library is very, very useful for this, because you can say, oh, I have this work to be done, but I don't need it done right now. I want to have it done whenever I'm going to have enough battery, or when the device is idle, or when I have network, or you can give your own rules and then say, yeah, just do this whenever you can, and the worker, the OS is going to spawn the worker and make it work whenever it's the more relevant. Also, of course, you need to track any memory leak that your library could do. So just like crashes, you want to make sure that you're not going to cause any memory leak, because basically, if your host application runs out of memory, it's eventually going to crash with an out-of-memory issue. You also want to monitor the library overhead, because you want to be able to tell the customers, yes, when you add the SDK, this is how much more CPU your app is going to be using, how much memory your app is going to be using, and how much network your app is going to be using. Because in the end, this is going to impact the end users on the device. And they're going to notice if you use a lot of CPU, because the phone is going to burn up. They're going to see if you use a lot of memory or a lot of disk space, because they're going to see it. And of course, because the network is usually going to go through a data plan, you want to be mindful of that. A very good thing is to keep a focus on performance. So if you find a way, and you should, if you find a way to track the performance of your library on an application, you need to have some monitors on this and get alerted whenever you have a new commit or a new version that's dropping the performance impact. So now we have a library. It's safe. It's efficient. We need to make it usable. And the user of the library are going to be developers. So we want to make sure that they can use the library as easily as they can. One of the first questions that you want to ask yourself is, are the features that I offer opt-in or opt-out by default? And this question is basically having a balance between, OK, it works out of the box, so basically just add the library and it works and it does everything, or it doesn't do anything that I don't know of. And basically, it's, OK, I want to know exactly what this library is going to be doing, so by default, it does nothing, and I have to manually say, oh, I wanted to do this, and I wanted to do that. So it takes more time to configure, but then you know exactly what it does. I don't have a clear answer to this because it depends a lot on what the library does. It depends a lot on your own preference in the matter. But this is a question that you need to ask yourself whenever you add a feature to know if you want to basically to have it working out of the box or to have it very configured. One rule of thumb that is good to keep in mind, though, is to make sure that the onboarding should work in 15 minutes or less. The idea is that someone that wants to try out the library shouldn't have to spend 8 hours configuring it and adding it to their project, because otherwise they're going to be very, very mad about it. Of course, you want to have as many things as possible that can be configured, because basically, your customers eventually are going to have to configure anything. Not everyone is going to configure everything, but you're going to have someone, every feature is going to have someone that wants to configure a tiny part of it. So you need to want to allow enabling and disabling individual features, allow tweaking the sampling rates, the thresholds, the configuration values. Anything, basically any value that can be configured and that's still, that would make sense for a user to configure, try to make it configurable. But of course, you want to use sensible defaults. So if a user doesn't want to spend 20 hours configuring every single detail of your SDK, the default value should be working the best for most applications. Especially for new customers, this goes with the onboarding thing that we talked about. If the default values and the default settings for the SDK or the library that you're compiling are sensible and works for 99% of the people, basically the new customers and the onboarding is going to be very smooth, because basically the customer are going to say, OK, I install it and I don't have to think about it again. Of course, to make your SDK usable, you need to communicate. This means that you want to log any actionable issue. So if anything goes wrong inside your library or your SDK, you want to add something in the logcat that says, hey, something went wrong, and this is how you can fix this. So basically, if there is a configuration error that says, hey, you need to provide a number that's between 1 and 10, and you provide it as 0, or you provided 20, please fix your configuration. Any feature misuse that says, hey, you tried to use this feature, but you didn't enable it in the configuration, or any key internal events. For instance, you have some communication that needs to happen with the backend, and you can say, hey, the communication worked correctly, or we had an issue sending the data to the backend because of a network error, or because of a permission, or because of credentials, or something like this. And for each of those issues, you need to warn the user, but you need also to say, hey, how can you fix this? So whenever you can, try to say, oh, try to look in this part of the documentation, or try to look in this class, or try to change the setting of this field in your configuration. So adding actions and documentation links in the message, and provide all the information about what the library is doing. Basically, you don't want the customer to try and guess what's wrong, because eventually, if something is not happening right, basically the customer is going to come to the support and say, hey, it's not working, and you're going to spend a lot of time trying to understand why it's not working. Having all those logs is going to help the support cases as well. So, library safe, efficient, usable. Now we want to make it future-proof, because you're not just writing a library, you're writing a library that's going to evolve over time. So what you want to do is keep track of the API surface. The API surface, it's any public class, any public method that you have in your library, and basically you want to avoid any breaking changes. Because basically, if you're between version 1.3 and 1.4, you change the signature of a method, or you change the constructor of a class, every customer that upgrades is going to have to go through their code and change everywhere they're using this class or this method. So you need to provide new options, but still keep the old ones working. So basically, if you have a method with a specific signature, and say, oh, I want to add a new parameter to this method, well, keep the old one and create a new method with the additional parameter. If you're using Kotlin, this is very easy because you can use default values for those methods, and the compiler is going to take care of everything. When you have something that you don't want people to use anymore, use the deprecated annotation, which work both in Java and Kotlin, but also add some login logcat. This goes with the communication, but basically you can say, hey, you're using this feature, which we have marked as deprecated since version 1.5. We're going to remove it in version 1.8, so please use this other one. Again, give something that's actionable. Say to them, OK, this is deprecated, but if you want to have the same feature, use this one instead. Also, if you do have API breaking changes, try to provide a migration guide. Usually, this is going to happen when you change the major version. So you say, I'm going from 1.x to 2.0. And you're going to say, OK, basically, we changed this class, we changed this pattern, we changed the way we use this feature, and provide a full migration guide that says, OK, this class doesn't exist, this is replaced by this feature, and so on and so on. I know that OKHTTP does it quite nicely. Java does it quite nicely. So they have this full thing. And of course, the Android X for the support, the AppCompat library, they did also a great work. Say, hey, if you're using this from AppCompat, use this from Android X. You also want to monitor the dependencies. Chances are when you're writing a library, you're not just writing the library on its own. You're going to have some dependencies, maybe to OKHTTP, to the Android system, to a JSON serializer or deserializer, to some other systems. So whatever you have, you want to upgrade the dependencies of your libraries, review the change logs of the dependencies, and be mindful of transitive dependencies. Transitive dependencies, it's basically the fact that when you say, oh, I'm depending on version X of a library, and this library depends on something else that I depend upon, well, when Gradle resolves all the dependency tree, it's going to use the highest version possible. So basically here, we have those two lines that says, hey, my library is upgrading to the Kotlin standard library to 1.5.31, but one of my transitive dependency that I'm not really aware of use the 1.3.61. And so it's automatically going to be upgraded to 1.5.31. And in some cases, having this upgrade means that methods that this dependency used to rely on don't exist anymore, or the method name changed, or the signature changed. This happened a lot with OKHTTP because some of the dependency between version, I think 2.13 and 2.14 changed a lot, and this can cause issues. So be mindful also of this, because this could create bugs in the future. Also, to be future-proof, you want to protect your experimental features, meaning that if you have something that's still in an early stage, try to create alpha and beta releases. The good thing about this is that usually people are going to be mindful and try not to use a version name of a library that has alpha or beta in it. They're going to be very cautious and wait for a production release. And also, you can use the Kotlin's opt-in annotations. The Kotlin opt-in annotations basically allow you to create a custom annotation. Here, it's going to be called my custom opt-in, and it uses this requires opt-in feature that says, hey, this API is experimental. And so anything in your library that's going to be annotated with my custom opt-in is going to generate a warning, actually an error in the IDE that says, hey, by the way, you're using this feature, but this feature is experimental. And so to be able to use this, the user are going to have to use this @opt-in to say, oh, actually, I want to opt in to this experimental feature, meaning that they know it's experimental, they know that it could break things, and of course, when they see this, they're going to say, oh, I'm going to look at the documentation to make sure that it's not going to break anything in my application. So, library is safe, efficient, it's usable, it's future-proof. Now we want to make it open source. Making it open source, it can seem easy because it could be just like, press the make public button, but you want to try to prepare yourself for this. first of all, why do you want to make your library open source? One of our core paradigm is that anything that lives within your customer's code should be readable and editable. So the SDK that we provide that lives in an Android application, or iOS, or React Native, or Flutter, this is some code that's going to live next to our customer's code. So we want to make sure that they know what we're doing and that they can change it if they want to. This is the most important thing, is that we don't want to do anything that they are not aware of inside their own application. Having an open source library also allows you to have direct contributions. We have lots of course, issues open, but we also have pull requests for customers that say, hey, I need this feature, and can we do this like this? This means that we also have direct discussion with the actual users of our library. And it gives it makes sure that we actually know what they want. And it's not a discussion that necessarily goes through the support. So it's more fastest. And of course, we're using open source every day. Android is open source. A lot of the SDK that we use ourselves are open source, OKHTTP, JSON, and so on. So it's only a good thing that we also contribute and give something back to the Android community. So when you decide to go open source, one of the first things that you want to do is write this contributing.md file. It's a markdown document that basically explains how to contribute to this repository. So you can explain what's the developer environment, the IDE, the tools, any specific program that you need to install on your local development machine to be able to build and run the code. Then you have the description of how to actually build and run the code. Usually with Android libraries, it's pretty easy. You say, yeah, open Android Studio, click the run button, and it works. Also, how to run the test and the static analysis, whether it's from the IDE itself or from a Gradle command line. Say, oh, if you want to test the library, this is what you want to run. Then, of course, you need to say how people can contribute, either by opening issues or opening PRs, and try to make visible what's the expectation in an issue or in a PR. In an issue, you can say, oh, I want you to tell me what version of Android you're using, what version of the SDK you're using, try to give reproducible sample, and so on. And for PRs, you say, oh, you need to write the test, you need to write the documentation, you need to do this and that. It's also a good place to write your coding conventions to say, hey, we don't use this pattern, we try to use those libraries, and all the guidelines that you have. I mentioned this. You want to say, what do you expect for a PR or an issue? You can actually create template files that are going to be used by GitHub whenever someone presses the new issue or new PR button. It's just going to fill the description field with this template, and they just have to basically follow the guide. So if you can use markdown headers, you can use markdown checkboxes to say, okay, just make sure that you did this, this, and this, and basically pre-fill everything to make it easy to interact with your repository. And the good thing is that the checklist and the templates are used for everyone. So it's always also used for internal developers that create PRs. So whenever someone in the team makes a PR, we also have this template, meaning that it is the way of working every day. Now, whenever we talk about open source, there is the big question of the license. I'm not a lawyer, so I'm not going to tell you which one to use. There is a great site that's called Choose a License, which is going to explain everything that's related to most of the license that exists out there. The number of open source licenses is huge. Usually, you want to try to use an open source license that is, a standard in the field. So in Android, most of the projects are either under the Apache or the MIT license, but there are many others. So make sure that the requirements and the restrictions of the license you choose are compatible with your dependencies. Now, a few guidelines that are more specific to Android. When you write a library, nowadays, you can add a manifest that's going to be merged with the host application's manifest, meaning that you can already say what your permissions are So if you want to use the internet to access a network state, to use Bluetooth or whatever, you can put it directly into your manifest, and it's going to be added to the host application manifest, which makes it much easier for someone to use your library. Also, you can add in the Android block of your build.gradle file, of course, a main SDK and target SDK to say which version you're compatible with. And this is the question that you need to ask yourself, like, what range of API do you want to be compatible with? But also, you can have the AAR metadata to say, what's the minimum compile SDK that I'm allowing? So the compile SDK is not necessarily the same one as the target SDK. Your target SDK, meaning you can say, oh, I need people to target at least 29 to be able to use my library. One of the good things as well is that you can create test fixtures, which is basically a way to provide code that users can use in their tests. So this has been added recently. Basically, what's happening is that you're going to have a test fixture source folder, or you can add some code that people can use to generate test data or mocks. And basically, they don't have to go around your library to write their test using it. So this is a very, very good thing to see. Next, we have, of course, the publish to Maven task. This is pretty standard. There's lots of plugins to be able to publish things to Maven. Try to go through Maven Central, but you can also have your custom Maven server if you want to keep track of your artifacts. But basically, this is something that's pretty simple to do. And as soon as your AARs are available in Maven, everyone can use it, so it's the best way to do it. Also, since the last Google I/O, we've had this Google Play SDK index that was released, which is basically kind of like a Play Store, but for libraries. So you can actually go in there and try to look at what SDKs exist out there, and you can see basically what's the activity of those specific libraries that are available in the SDK index. There's also a Google Play SDK console, which basically is the same as the App Console, but for SDKs, which is not open yet, but basically it's going to happen soon. And this is a good thing to do as well, because you can interact with your users through this. In conclusion, when you're writing an open source library, try to keep an open mindset, because every mistake is a lesson, and there's going to be a mistake because, I don't know any long-term project that doesn't have any mistake. So every mistake is a lesson. Try to improve over time. And if you want, you can take a look at other open source libraries, not just to see how they are coded, but also how the project itself is worked on and how it's maintained. If you want, you can take a look at our repository as well. Everything is open source, so you can see how we set up our CI, how we set up the contribution guidelines, how our PR evolve. And that's it for me. So thanks a lot, everyone, for listening. And if you have any question, I think we have 5 minutes for that as well. Thanks a lot.